Hello. Well, today we're doing comes with you a little bit of excitement and sadness because today is actually the last day of the build your own electronic sound synthesizer, the Advent days that are videos that I've been doing, and we have had quite interesting synth. I mean, it's only got 4 notes in the sequence and only does really sound and sign. But hey, we started off with an LED flashing and a simple speaker click, so actually it's gone quite far in such a short time. So we're going to open the final door. Tomorrow, remember, Christmas Day, Christmas dinner. Oh yeah. And what have we got? Another final door. I'm taking my time. We have LEDs. We have 4 LEDs. Okay, so 4 LEDs. Let's see what we've got in the book. And what's interesting is there's quite a few more bits in the book, so we're going to have a look at those in a minute. But these LEDs, look, we have a ton of LEDs here, adding more sequence steps. So let's have a good look and see what's changed, because there's quite a bit that's changed, I think. So we'll start with this side of the board, because I don't think a lot has changed on this side of the board. Let's just see. Yep, those have not changed on this side. So let's see where all these LEDs need to go. This is a sleeves up moment just because there's a few. Remember, the long side goes into the top, into the positive. So I guess we keep going then. So we have pin 12 and pin 11. I believe that's right. No, look, pin 11 doesn't have one. Oh, no, but look, they've got these jumpers here. So actually it carries on along this way. I see. Oh. Okay, so what happens there is actually there's a gap I missed. So there's 3 that carry on out that way because these other pins here are being used for the sound out. So they're being used for sound out. It's got to come from some of the other spare pins. And to be fair, I think they've used the GPIO outputs on this controller quite well because there isn't really much spare left. Now, let's look at this bottom half here because that's kind of important. So we are going to take away this jumper and that jumper stays, that jumper goes. So 2 of those are gone. Just got this one, which is on pin, what's that, pin 6? No, 7. Pin 7, and that's pin 7 there. Okay, right, let's pop those into this drawer here. And I've got some reusable bits of jumper wire here, and if I do run out, I have a jumper wire kit. So this is why they said to save some, because today there's a fair bit of jumper wire going in. So we've got connection from pin 10 going up. And which of these is shorter? We'll use the shorter one for that. So that's pin 10 going up. And it's quite tricky to see what we're doing, so I'm having to go by feel here. So this wire is actually a little bit long for this purpose, but I can just go further up the same, as long as it's on the same breadboard row. Because if you think about how the breadboard is connected, I'm going to need my pliers to get in there, aren't I? Because that's tricky. There's just Not quite enough room for my fingers in there. And I think, just so I can move the board around, I'm going to disconnect the speakers. It keeps popping out, that's frustrating. Wow. So here is where it gets super fiddly. Hands up who didn't expect this to get fiddly though. It is, yeah, it's a lot of electronics to fit on these boards I suppose, although I've seen denser. If you've not come across him for breadboard stuff, there is a YouTuber I rather like called Benita, and he does breadboard computing stuff, and he does a series where he builds 6502 based breadboard computers. Now, I'm rather a fan of the 650, well, actually 6502, although it was a 6510, which was the Commodore 64's processor that I first learned BASIC and a little bit of assembler on. So I'm rather enjoying following Benita and his exploits in making a 6502 based computer. It's interesting stuff, I think. Okay, so we'll bend this one round and put that in for the next connection. Wow, that's far too long. Okay, well, we'll use that for the third one, because the third one goes across to what I think is pin 6 here. It does kind of match down here as well, so that's handy. So we'll put this one in pin 6. And I'm going to go this way instead of sending it down and round. There we go. That's pin 6. And then we need one more for the middle. Oh look, we're going to have plenty of wire left, because although I've not been sparing in my use of what I've cut off, I have been sparing in reusing jumpers when I can. One of my habits, for better or worse, is I like to throw away nearly none of what I've been using in my lab. Maybe just the insulation I strip off, but I don't like to throw away too much. So, let's see. Right, so they've got that going just down from here, and you know, I guess that is neat, but so from there, and if I put the bend in the right place, let's put the bend a bit further in, like that, and we leave some up there for insulation, and it's going to go to pin 9. Is it? No, pin 8, because pin 9 is already in use, so it's pin 8 that's in use for this one. So if I cut it about there, I think. As always, I put in my nice bend, and my nice bend is going to come out as soon as I try to strip it. Let's see if I can keep the bend in and strip it. Ah, bend's still in. So I put the bend in just so I have a wire that will fit the purpose. I've forgotten which way up it was. It was that way up, wasn't it? So we will bring that over and bend that side over too. There we go. So it's like that. Right. This is going to get tricky. I see why this was going down. So we'll just bring it down also like that. So that's exposing that hole for pin 8. Got snagged up there. Let's try not to snag that. Okay, good. So let's push this side in. And I'm still balancing on the cardboard box that is now empty. Let's wait for the calendar box. There we go. Right. Those are in. Now let's just check. So 11, 10, 8 and 6, and there are no further jumpers there. We've still got the same other wiring down here. Just going to be wary of where those are. There we go. Make sure none of these resistor legs are touching where they probably shouldn't be. It doesn't matter actually if they're connected to the same breadboard line, but still probably better. They're not touching well. Yeah, make sure this is not touching the legs of any of those resistors, because that would make some strange things. And just line these up a bit. There we go. They're a bit more lined up now. So we've got 8 LEDs there. Nothing has changed here. So as today is the 24th December, you should press and hold the 2 middle buttons before and while you connect the power supply. So the 2 middle buttons, I think, are still selecting a program over here like the jumpers would. So I see. Let's connect our speaker back up. I'll put it there since that doesn't matter greatly. And there. There we go. Speaker's connected. It's got to go in this pin 5, remember that. And if I hold down 2 pins, do we get a Christmas song? Before and while. We have a Christmas song! Okay. Oh, it does repeat then. So there's something nice and tuneful. Oh, it doesn't do the next phrase though. Oh well, I mean, I can't be too fussy. But look. So it plays the Christmas song, which is very nice. And this pin here. I don't know what these other 2 here are doing then, but this is almost like you've got counters for which note and then counters for which bar the note is in. Which means you can actually probably program, what, 4 times. Can I switch between square and sine? Nope. Okay, so there's no control. No control with the controls right now. Okay, but there are many more pages in this manual. Should we see what else we have? Let's knock that off for a sec. Anyway, Merry Christmas, given it is Christmas Eve. It is the 24th. Let's see what else we have, because there's a lot in here. Sound machine. Your sound machine is now complete. When you are sure you do not want to repeat any of the previous experiments, you can shorten the wire to fit them snugly on the breadboard. I might not do that. However, do not shorten the legs of any components. It's recommended you place the sound machine in front of you as shown. So the LEDs are on the left side and the push buttons on the right side. Okay, just disconnect power while I move this around for a second. Let's reorganize this desk because we don't really need the box anymore. So get rid of this box. Might be a useful component store, I don't know. So they recommend we put it this way round, do they? The buttons are on my right side and the LEDs are on the left side. See, I still kind of prefer it the other way up, but fine, okay. LEDs represent binary digits. Yep, okay. 1, 2, 4, 8, 16, 64. For example, when the 2nd, 3rd and 5th, they represent value 22. When they're off, represent 0. Sound machine has 8 modes. Switching between modes is powered up is only possible between modes 0 and 1. So programming and playback. Select, disconnect this, hold down the combination of buttons shown in the table which corresponds to the mode you've chosen. Oh, okay. So we can do different sound machine things with this. So if I plug this in again, and we want the Atari Punk console, what can we do? 0, 1, 0, 0. So that might help. I stuck it into the wrong place. Silly. There we go. True. 3 oscillator synthesizer. Oh, what do we get with that? Oh, I see. So 3 oscillators controlling the synthesizer. So it's not polyphony. It's literally 3 oscillators feeding through to control first the frequency of the synthesizer, then the frequency with which that is cut, and then a frequency on cutting it further. Okay, kind of fun. Tuning. So we hold down this one. What do we get with this? Okay, so you can just tune maybe it tunes what the other ones do. I don't know. I'm going to put it back to the same tune. Tuning length adjustment. So I guess that allows us to adjust the length of notes. Christmas song we've seen. Reset, I suppose, resets everything to factory settings on the chip. Okay. Mode 1 playback. When the player supply is connected, so mode 0, sorry, which is nothing pressed, we get playback of whatever the last scale. So stored scale, okay. Button D switches. It does indeed. Button B stores it. C short for notes are erased from machine. Does not apply to permanently stored sounds. They're still available. The first LED lights up. Mode 1. Oh, and this now takes us into programming. You can change the currently selected pitch, note and volume of up to 256 tones. First selected is always the note assigned to 0. None of the LEDs light up. So played repeatedly. So C and D. Okay. Value set with the trimmers, P1 to 3. Press B. No. Which one? Haven't quite worked out how to change the tone. Ah, like that, okay. That change, it's still the same as it was then, still. Right, volume, length, pitch still. So then if I say switch this, we get okay. Hold down. There we go. Is that less or more? Okay, now we switch. So we have changed that note. Okay. That could be fun. Could be some time to actually program some other sounds. It's not always appropriate to choose a maximum volume. We have heard that this speaker's being to vibrate when you do that. So yeah, that's fair enough. Sound quality is better at level 6 or 5. Oh, does it actually show? Oh, I see. So when I'm adjusting these, I think we're seeing some readouts here. Is that... Oh, wait a minute. I might have missed what was going on there. So if I... Okay, so if we go... And then we... Ah, look. So these are showing... Ah, so that's when it's off the bottom. And you can see this is a slightly dodgy potentiometer, I think. Can I get down to 1? There we go. So we can actually see the binary. So what's that? That's 10, 11. Okay, do we get the same with this pitch? Okay, so that goes up to, what's that, 30, 33, no, hold on, 13, 16, that's 40, 49? Can I go down to 1? 0. 1. Oh, can I get it to 1? There's 1. Oh, bit iffy to get that one. There you go. What's that? 7. It's quite hard to get the semitones, but they're definitely there. Okay. That's handy, so I can program it using these tones. That's going to be fun. What else have we got then? So it talks about the length. 1 to 9, okay, it's not quite counting. 1/8 of a note. We've got 11 is, well, 1/8 of a note and a bit. Okay, so they're showing the different note values using the middle potentiometer. Means that it and all subsequent notes are not played in mode 0. Instead, the playback starts with the first note. So it would repeat it. Strange. In mode 1, length notes are played repeatedly for a very long time, which is what we were hearing, but that's not really what I wanted. Okay, well, that's fine. That'll be okay. Lengths assigned to values 1 to 17 have fixed relationships to each other. Right, but then I suspect if we talk about length adjustment here, that might basically set the tempo of the whole song. Tuning might set the frequency of the whole song. From one even number to the next, so 2 to 14, the interval doubles, an interval increases it by a half. So an even value by a half, right? Reasonably translate to the lengths generally used in musical notation. Fair enough, yeah, okay. So what you got your tone, your semitone, no tone and semitone. I'm thinking of the actual notes, not the lengths. Was it a breve, semi-breve? Oh, you're testing me now. Pitch range of about 2 octaves. Okay, I don't really know what the notation with the single quotes are, I'm afraid. I just know that's C to C sharp. So is that a lower octave and then 2 octaves above C sharp? Values 0 to 25 of the individual tones. So that's a kind of a scale. And these are showing the semitones of the scale. So every whole note is a tone, every half note is a semitone. Yes, the old scales, tone, tone, semitone, and all of that. See the trimmer values for Beethoven's Ode to Joy. I might program that later. I'm not going to make you watch me programming that. When the same tone is played twice in succession, difference must be audible. To this end, you can insert the same tone again between the 2 occurrences, but with a shorter length and lower volume. Okay, because then it'll change the tone. Whereas I suppose if you had the same tone with a shorter length, it might just extend the last one. Complete the melody with a long tone at volume 0 in memory location 20. Placing additional tone with a length 0 at the end, location 21, causes the sequence to be repeated. So you could do the repeat there instead of having the rest of it. Handy. In this song, the length value 12 and volume values are used quite often. Convenient to program all the notes first with a length 12 and volume of 6, then adjust the values in a second pass. I see. Because what you set these to, if you keep pressing the button, it'll set each of the next notes in the program to what you set it to before. No, well, there isn't a store button, was there? There's a skip forward. Oh, I suppose actually B. Yeah, okay, so B would be your store. So you could just skip through storing and then skip through and then store the values that are different from the 6 and 12 combination of time and volume. After completing, switch to mode 0 and listen to your piece. To store it permanently, press button B in mode 0. Okay, we might have a go at that in a bit. What else we got? The Atari Punk console, you saw me play with that. 3 oscillator synthesizer. 3 square wave oscillators influence each other. 1 sets a frequency to 1 to 500 hertz. Affects 2, which in turn affects oscillator 3. So it's like, basically it's like the Atari Punk with 1 additional layer. Okay. 2 LEDs assign the output signals and the individual oscillators. Tuning, current value, preset value can be changed with this. Change to effect in mode 0 and 1, save it by pressing button B. So it is what I thought. So you'd actually be able to set the key of the playback mode 0 and length adjustment, basic tone relationships, fixed length. Again, this affects mode 0 and 1. So what I thought. Christmas song replayed repeatedly. This will reset and take us back to a scale. Okay, what else we got? Oh, okay. This was the stuff we saw about the speaker. Well, I think this has been fun. I think I might have to go and see if I can put in the Ode to Joy and see how it turns out. That's some of the way towards Ode of Joy. I've got to be honest, that takes a fair amount of setup to get a whole song here. So one observation I've made, the more I've used this, the more I've ended up with green streaks in my eyes for a while afterwards by being dazzled by these. They do warn it before using it as a control panel, but what I'm wondering is if I could use this, as in the paper, since, you know, even if I do go back for the experiments, it won't miss a corner, to make a slight diffuser for them. Now what would be really nice if one of those bar graphs would line up just enough, or if I could see just enough of the LEDs underneath to still see the binary values that are on them, but without perhaps dazzling my eyes so much. Maybe a pair of scissors and a bit of blue tack and the job's a good one. Let's see. Okay, my insanely large scissors. I will go through this corner here and that corner there, and then I can carry on my Ode to Joy. At the moment it's my Ode to So Much Joy I Can't See. There we go, and if I just blue tack that on there, and we'll just trim off one end of it over here as well. Let's trim off somewhere like there's a little bit of excess. There we go, perfect, nothing goes to waste. Okay, bit of blue tack as well. I'll just roll it around a bit. I only really want to shade them. I still kind of want to be able to see the individual LEDs. But it's if I can just shade out the bit that is making my eyes most hurt. And if I just make sure I don't nudge them all out of line. Pop it about there. Hold on, this blue tack needs more working. It's actually white tack, but it is still it's still really blue tack, I guess. It's just not blue. I wonder why the blue tack company is now making them in white, huh? Actually stick it to the LEDs first. Stick the LEDs in it. I've just got to stick the paper on top. It's not beautiful, it's just functional enough to save my eyes. And there, now, if I turn it on, so from that side you can kind of see the bottoms. From this side it's still pretty bright. Can I adjust it over? There we go. So I can see the bottoms. I'm not staring right into the LED. Like that. And that will not leave my eyes dazzled. And in case there was any fear this would go to waste, I've got this box of jumper wires that I've had probably for the best part of 20 years actually, which I replenish here and there as I reuse things from old Breadboard projects. And to be fair, these pre-cut jumpers, there's a slot for those right in the end here, which I've also kind of stick some old, actually I stick old ends of LEDs and things that I trim off as well. And I'll just put this in the longish wire here. It's single core, it'll fit where they fit. The only thing that really shouldn't be in this box is this multi-core cable, but meh, it's there. Better that than it's wasted. Look, there's a spare leg from yesterday's efforts there too. Cool. As the feature suggests, we really do have. We've seen the punk console mode. We've now seen the 3 oscillator mode, although I thought there was going to be 3 oscillator polyphony, not quite 3 oscillators with 2 chopping each other and 1 actually making the sound. We have actually got a 256 step sequencer. That is cool. Something I can play with. And to be honest, if you've got more electronics news, I guess you could start taking this further and maybe putting in, I don't know, controllers that can do more with the sounds. It looks like we still only get square and sine for the whole track, and we can't do it per note. So, I don't know, but it's a pretty cool kit. I mean, overall, I think I've had fun. I hope you've had as much fun watching me make it as I've had fun making it and doing sounds with it and playing with it. So I think it's been a pretty good build up to Christmas. Makery, fun, electronicsy, and bleepy bloppy. Cool. Other than that, I hope you have a really, really Merry Christmas. And I've had fun making these videos. I hope you've had fun watching them. And go make stuff and be awesome. Bye. Does it play? That's my ode to so much joy my eyes hurt. Receipt.